Alrighty, CNT120, Chapter 2. We're now continuing on with the section on cabling. And we have a couple different types of cabling we're going to talk about. Your patch cables in the work area, the horizontal cabling coming from the work area back to the closet, and then the backbone cabling connecting our two closets together. So let's take a look at the first one, patch cables. Patch cables are a short cable that allows us to connect something like our computer into the outlet on the wall, patch panel into a switch port, those kind of things. You know, your PlayStation into your switch at home, that kind of deal. That's what it's designed to do, and it's usually designed to be relatively short distance. A lot of times like 10 or 12 feet kind of thing, not too long. This part of my network, they say here less than 10 meters, less than 30 feet. Yeah, it's not usually meant to be too long to connect from workstation into the outlet on the wall. Also, the patch cables are used in my closet to connect from my patch panel to my switch ports. From my patch panel to my switch ports. In the other diagram I had for you, patch cable going from the computer to the outlet on the wall. Typically, we try to keep it 5 meters or less kind of thing. And then in my closet, going from the patch panel down to the network switch, your switch port, if you will. Again, we're trying to keep it less than 5 meters. A lot of times in the closet it is much shorter than that. Sometimes it's only a few feet, if that, to connect from your patch panel down to your switch port. Here is the kind of thing we're having for a patch cable, okay, with our RJ45 modular 8-pin connector on the end to connect in. Again, when we talk cabling in Chapter 5, we'll talk about the color code pinout that we have here, 568A color code and 568B color code. Something I want to kind of put on your radar is this type of cabling here, this patch cable. If I cut away the insulation, look inside, the conductor is what they call stranded. It's made up of a bunch of small wires twisted together to carry the data signal. Well, these couple wires twisted together like that allows this cable to be more flexible, bend around more before it breaks. That's the kind of cabling we have for our patch cables. That's what it's designed for, that flexibility. But it also kind of limits your distance. If I start trying to make this a really long patch cable, I might actually have data connectivity issues. The signal might start weakening too much. That's why we usually try to keep these patch cables relatively short. The next type of cabling we run into is the horizontal cabling. The horizontal cabling is going to go from that work area into the data closet, into the patch panel. The maximum allowable distance for our twisted pair cabling is 100 meters. So what they usually denote is 90 meters should be the max for this horizontal cabling. 90 meters for the horizontal cabling between the outlet box and the patch panel in the closet. So this part of the cable run from the outlet into the closet. This part of the cable run from the outlet into the closet. This part of the cable run from the outlet into the closet. That is your horizontal cabling. And if you look at the drawing I did for you, from the outlet into the closet, into the patch panel, if you look at it, it's mostly going horizontal across the floor. In a building, let me go back to this one, the cabling is typically going up through the wall, above the ceiling, supported in cable trays down the hallway, and then into the closet, you know, kind of drop down and into the closet and punched into the patch panel. So the majority of it is going horizontal across the floor like this, horizontal across the floor. That's why they call it horizontal cabling. That's connecting your work area outlet back to the patch panel in the closet. And each one of these cable runs coming into a patch panel port gets labeled and identified, so you know it's going to this, you know, this room or this lab room or this classroom, this port on the wall. That right there, they're saying 90 meters max is what that should be from the outlet into the patch panel. If I look above ceilings, I start seeing this. Cable trays supporting these bundles of cabling going down the hall and into rooms or classrooms or into offices, that sort of thing. On the back of the patch panel, it's punched in, and then each of those punch-ins corresponds to an outlet on the front. Horizontal cabling gets punched into here, and then I can use a patch cable on the front to plug into that from that port into a switch port. Okay, and there's my closet there where I'm punching into the patch panel. Here's the horizontal cabling coming in and then down the rack and into the back of the patch panel. It's coming into the back of the patch panel there. Horizontal cabling coming down the hallways in these trays being supported as they go around corners, nice gentle bends, and then down into equipment racks or down equipment racks and into patch panels kind of thing. That again is your horizontal cabling. Okay. The other end of the horizontal cabling is the outlet at the work area. The outlets in the offices and the classrooms and so forth. The outlets in the classrooms and offices and so forth. Okay, so the horizontal cabling is going from that outlet, above the ceiling, down the hall, into the closet, into that patch panel. Going from your patch panel above the ceiling, down the hall, and into the outlets on the wall. Now, we said earlier that the patch cables were a stranded conductor for flexibility. Well, this horizontal cabling that's going from the patch panel to the outlet is actually a solid conductor. This is all the insulation, everything cut off, and you see it's literally just one piece of copper cable. Think of it almost like a paper clip. It is a solid piece of copper that is my conductor. Now, this, if I bend it a whole bunch, is going to break, just like a paper clip. If I bend that a whole bunch, it's going to break. So this is designed to be installed, punched in, installed, and left alone. And for the most part, you might not move it for 10 years. So it'll be fine. It won't get moved a lot, and therefore it won't break. But the benefit is this carries your signal a lot better, a lot less signal loss on this, a lot less resistance with this solid conductor as opposed to that stranded conductor we looked at earlier. So the patch cables using stranded, I'm getting that flexibility, but I got to keep the distance short. The horizontal cabling, I'm using the solid conductor. It can break if I bend it a whole bunch, so I install it and leave it alone, but I'm getting the benefit of a better, carrying the signal stronger for a longer distance, if you will. The last type of cabling is our backbone cabling. Our backbone cabling is the cabling typically connecting our two closets together. Typically connecting our two switches together, if you will. The switch in this closet to the switch in the other closet. That is typically your backbone cabling. Typically going to be fiber optic cabling for distance. That's the main reason, distance. Well, if I'm dealing with a campus, again, think about, Hacks campus, if you will. I might be using fiber optic cable to connect the buildings together. Now, this is showing a convention hall and so forth. But think about connecting Blocker over to the Student Center, Blocker over to Hall Tech, Blocker over to Whitaker Building or the Arts Building and that sort of thing. Those distances are large enough, they're beyond the 90 meters, that I would need fiber optic cabling to do that. And fiber optic cabling in a LAN environment like that can go 500-600 meters easily. But I can switch over to different type of fiber and start going kilometers in distance before I need to worry about boosting the signal, if you will. So my backbone cabling is typically connecting my closets together. Sometimes they're above each other in a building, so connecting my closets together like so. And I'm really going from switch to switch, switch to switch. That's typically what you're connecting together, especially in the type of networks most of us will be working in. Connecting my switch or my closet to closet, switch to switch kind of thing. Here I'm showing you going literally from switch to switch with a fiber optic cable. And I'm typically going to run into this type of thing. Here's some fiber optic cable, leaving my switch going to, down through the floor to another closet. Here's a whole bunch of fiber cables coming down the rack and into it. Here's a bunch of fiber cables leaving and going down through a hole between the floors, if you will. Yes, you drill a hole between the floors, put a conduit in or a sleeve in, run the cabling through, and you put some of this, it almost looks like clay. It's called fire stop, keeping, if there would be a fire in a room, keeping it contained in that room. When I'm there's our three different types of cabling, our patch cable, horizontal, backbone. Now, when they start talking cable management, there's some things we need to do or not do. When terminating any kind of cabling, your twisted pair cabling, I don't strip a lot of the jacket or insulation off. Doing that too much allows for what's called crosstalk. That is literally signal jumping from one cable to another cable, or another wire from one wire to another wire. So when I'm terminating, I don't do a lot of untwists like this. I try to keep the termination up next to where I'm punching it in. When I'm routing my cable, I need to make sure I use nice gentle bends around corners. Sharp bends can cause my cable to not perform at the best level. I might actually have some signal loss if I have a tight bend there. And they call for a 4 times the cable diameter as my bend radius. And as you see here, we're doing nice gentle bend radiuses. After I put a cable in, or cable run in, I'm going to use a meter to test to make sure I have continuity. Meaning, can I potentially send data across? Do we have a full circuit? Here's a continuity meter that actually uses a battery and will send a signal down, example pin 1, and look for it to come back on pin 2 across that cable. They also make wire mapping meters that will send a signal across and look for it to loop back and come back the other wire, giving you a full path. We will use those when we do our some of our cabling in Chapter 5. As I bundle cables, I usually want to avoid these plastic cable ties, if you will. I usually want to avoid those and use Velcro cable ties in preference. These are a lot gentler on, especially if I don't pull hard on it, and allows me to open them, add more, and close it back up. That allows for adding and removing cables pretty easy and keeping them bundled. If I have to have any cables in the floor, I need to make sure I protect them with some kind of raceway. And if I'm dealing with fiber optic, I typically use what's called interduct, which is a conduit allowing me to run my cabling through to protect the fiber optic so it does not get crushed by other cabling. When I'm routing my cabling, I'm looking to avoid sources of EMI, electromagnetic interference. Things like lights, motors, power cords, elevator motors kicking on and off, all produce what's called electrical interference. And my data cabling can pick that up and actually start drowning out the data that's in the wire. So I want to avoid those sources of EMI, and they're saying at least 3 feet away from a lot of these things. So when I'm routing cable or planning where cable trays go to route cable, I'm looking for those sources and trying to make sure I stay away from them. As I'm routing cable, if I'm going above a ceiling and down through like the hallway, that could very well be a plenum space. A plenum space is where I'm moving air through a building. And if I have cabling up there and there is potentially a fire, that cable melting could be pushing toxic fumes through that hallway to another part of the building. So that area up there is what they call plenum space. So the cabling I put in there needs to be plenum rated, meaning the jacket insulation is such that the plastic, it's not fireproof. It still could burn, but the toxic fumes coming off that is going to be very minimal. It's such that the plastic on there is not leaving off near amount of toxic fumes that you would have on regular plastic insulation. So there is ratings for, if I have a patch cable in a room, it could be general rated. If I'm going between floors, it can be riser rated. And if I'm installing above a ceiling or even potentially below a floor, that's a plenum space, it would need to be plenum rated. And when I get cabling, there's a code that I can look for to show whether it's plenum or not. If I look at this box here, okay, and I look at the cable here, this is showing this is just plain old patch cable. So that is not plenum rated cabling. Okay, that patch cable right there. Meanwhile, if I look over here, category 6, this shows me just kind of basic cabling, if you will. Here, as I look at it, I see CMP, that is plenum rated cabling, and the box tells me it's plenum rated cabling. So I would need to look for that if I'm installing cable or purchasing it to install the cabling. As I'm hooking up my equipment racks, I do need to worry about grounding them. So if I have an electrical short, it's not going to energize the rack and all the cable support in hallways. So there is actually grounding wires that need to be attached to them and attached to building ground. As I'm routing my cable, I need to make sure I leave some slack. That way I have that to uncoil and move equipment racks around or potentially service equipment, then put it back. So I need to make what they call service loops. My cable trays should be supporting my cabling from closets out to work areas and so forth. I'm going to pick up here in the next podcast.